Episode 2, The Radio Died and I Smashed the Tube with a Hammer. Series, The Detrola Challenge. Hello everyone, this is Professor Edney Rossi, and welcome back to the second episode of the Detrola Challenge. In our previous adventure, we introduced our patient, an 80-year-old Detrola tube radio, a relic filled with dust and stories from the past. Today is a day of action. Opening sequence. I tested the tubes one by one. 2 of them had broken filaments, so I replaced them with healthier tubes from my spare parts collection. I rechecked every connection, measured capacitors, prepared the classic troubleshooting trick, the series light bulb, to power on the radio safely. With everything in place, I flipped the switch, and then silence. Not the respectful, contemplative kind of silence. Instead, a sudden flash, bright and intense from one of the tubes, and just like that, the radio flatlined. Yes, fellow soldering iron warriors, the heart of the Detrola has stopped beating. Our brave rectifier, 35Z5GT, has left us. She has gone to that magnificent vacuum tube afterlife, where electrons roam free and filaments glow in eternal thermal peace. But do not despair. This is a workshop, a laboratory, where loss is honored by science, not sorrow. It's time for the technical scientific autopsy. I grabbed my trusty precision tool, my Seri technical adjustment instrument. Okay, it's really a hammer, but calling it a technical adjustment makes it sound far more academic. With great care and safety gear on, we shattered the glass envelope. What we discovered inside was nothing short of mesmerizing. Inside the tube, the filament, ultra-fine like an incandescent bulb's filament, glows white-hot and releases electrons, a process known as thermionic emission. The cathode, a heated metal sheath surrounding the filament, amplifies and releases more electrons into the vacuum. And finally, the plate, or anode, a metal structure that attracts electrons but only allows one-way flow. There you have it, a vacuum tube diode, the vintage rectifier, an elegant and warm version of a modern semiconductor diode. Opening a vacuum tube is like unwrapping a time capsule. You see, touch, and truly understand the engineering inside a bygone era. While you watch the dissection of our departed 35Z5GT, let's dive deeper. What exactly is an electronic tube? What is an electronic tube? Also known as a thermionic valve, or in English usage, vacuum tube, this glass bulb once powered the cutting-edge devices of the early 20th century. These tubes resided in radios, guitar amplifiers, laboratory gear, and early computers. You've probably seen one, that round glass bulb with visible glowing filaments. But did you realize it was the heart of what we once called modern technology? Let's explore how it works, who invented it, and why it still captures the imagination of musicians, engineers, and vintage electronics enthusiasts like me. How it works. Imagine a glass container evacuated of air, like outer space, devoid of molecules. Inside, at least 2 electrodes, a cathode and an anode, often called the plate. The filament heats the cathode. At sufficient temperature, electrons are emitted through thermionic emission. These negatively charged electrons are then attracted to the positively charged anode and flow through the vacuum, but only in one direction. That's the function of a diode. Now add a third component, the control grid, a wire mesh placed between cathode and plate. A small voltage applied to the grid can control a much larger current from cathode to anode, creating amplification. This is how the triode came into being. Amplification in a single tube. It revolutionized electronics and became the foundation of rock and roll and early broadcasting. Who invented the vacuum tube? Let's travel back to the late 1800s when electricity and incandescent lamps captivated the world. In 1883, Thomas Edison noticed a curious phenomenon. Current flowed inside his incandescent lamp from the hot filament to a nearby metal plate, but only in one direction. Though he didn't fully comprehend it, Edison patented the discovery, later called the Edison effect. By 1899, John Ambrose Fleming, a British engineer working with Marconi, had the insight to use the Edison effect to detect radio signals. In 1904, he created the first working electronic tube, a diode, later known as the Fleming valve. But the real leap came in 1906, when Lee DeForest, an American innovator, added a control grid to the Fleming tube. His invention, the Audion, was the first triode, capable of amplification. Although DeForest didn't fully understand how his audion worked, entangled with Fleming in patent disputes, history honors him as the father of the electronic valve. Subsequent developments produced tetrodes and pentodes. Engineers like Irving Langmuir at General Electric refined vacuum quality and electrode geometry. The result? Tubes with better gain, lower noise, and greater reliability. By the 1930s and 1940s, tubes powered radios, telephony systems, military equipment, airplanes, and even early computers. The golden age of tubes. Between the 1920s and the 1950s, vacuum tubes dominated. Radios filled homes. Early computers like the ENIAC used over 17,000 tubes. When one tube failed, systems often ground to a halt. Then came 1947, when John Bardeen, Walter Brattain, and William Shockley at Bell Labs invented the transistor. Small, reliable, cool-running, and cheap. The electronics world began to shift. By the 1960s, transistors replaced tubes in most roles. But tubes never vanished entirely. Why? Because they sound different. Warmer, more musical, more human. Many audiophiles and musicians still swear by tube amp tone and natural harmonic distortion. Types of tubes. There are many kinds of tubes. Let's highlight a few iconic stars. Diode, cathode and plate only, used for rectification and detection. Triode, adds the control grid, basic amplification. Tetrode, includes a screen grid to boost gain and reduce capacitive effects. Pentode, features a suppressor grid to manage secondary emissions. Beam power tubes, e.g. 6L6, EL34, preferred by guitarists. They deliver high power with reduced distortion. Each tube type is like a band member. Some deliver smooth treble, others punchy bass. Together they create sonic magic. Are vacuum tubes still used today? You might ask, why use these fragile, hot, expensive glass tubes in our digital age? Because they have soul. The filament glow, warm tone, organic response. Tubes do more than amplify a signal. They interpret it. In hi-fi systems, many insist that only tube amps deliver a truly warm sound. In recording studios, vintage tube microphones remain prized. And in guitar amps? The characteristic tube compression and harmonic distortion are legendary. Yes, tubes run hot, wear out, and carry a price tag. But much like vinyl records or analog film, their character cannot be digitally replicated. The future, tubes in the 21st century. Have tubes disappeared? Absolutely not. They are still manufactured in Russia, China, Slovakia, and by boutique tube makers worldwide. There are modern innovations like Korg's new tube, which mimics tube sound in a compact, low-power module. For DIY builders and tinkerers, nothing beats firing up a 12AX7 on your bench, soldering in valves, and smelling the nostalgia in the air. It is tactile, it is retro, it is real. Conclusion, long live the tube. Next time you see a glowing glass tube inside an antique radio, or hear your guitar amplifier roar to life, remember, this small artifact carries a living piece of technological history. Vacuum tubes may be old, but never obsolete. They are timeless. In a digital world, they remind us that there's still room for warmth, glow, and a little bit of magic. So what's coming next? All of this sets the stage for our upcoming episode, because now, without our rectifier tube, how will we power the radio? You're about to find out. Stay tuned, share this with your fellow tinkerers, leave a comment, and as always, long live vacuum tube radios.